Let me introduce David here. He will talk a little bit about our packaging system for Arch Linux, the mostly interesting internals, and maybe how to change them interestingly. So feel free, see you on stage, have fun.
Thanks a lot. Hi everyone. It's nice to see a bunch of people in here to actually listen to this. That's encouraging. Also a bit scary, but it's nice. So let's jump right in. Just to give you like a quick overview, I'm going to do a bit of a background thing, talk a bit about the motivation of this entire talk actually. And of course the oxidation factor, that's very important. And what further things will and can be done. So yeah, a little bit about me. I'm a freelance software developer. I am one of the Arch Linux package maintainers. I'm a developer and also main signing key for the distribution. I'm mainly working like pro audio things, Python, Rust installation process, packaging, a bit of infrastructure work too. It's a bit of a mixed bag of everything and nothing, which makes it kind of fun, I think. So we of course need to do the obligatory thing. Who of you here uses Arch? Oh, that's nice. That's like probably 50% or more. Then I'll still do a bit of like background for the people that don't or don't know anything about it. In the context of this talk, I'm going to talk a bit about Pacman, the package manager, which is written in C. That's basically the heart piece of the distribution with which you install all your packages. We have makepkg, which is the package build tool that's written in Bash. It's also part of the same project as Pacman is. Well, we do distribution packaging, which is based on pkg builds. Those are build scripts, basically, also in Bash. We now host them in our GitLab. And below that link, you will find all the packages that we have. We use DevTools for our distribution packages, which ensures that we build the packages in a clean CH root, which is like an environment that only installs the necessary packages to build the package or to run the package, usually. And then we have db scripts, which is a set of scripts that is mainly used for maintaining the binary package repositories. So that's where all the packages end up eventually that you as the user can install from. Was that the last one already? No, we go further. We also have the user repositories. You might have heard of the Arch user repository or the AUR. That is a platform to provide and discuss pkg builds. And a lot of people actually use that also actively to push pre-built packages into unofficial user repositories from which you then can install with Pacman. There's a long list there, basically. There's a gazillion AUR helpers to probe the AUR for packages that exist or to install from the AUR directly by building the package and then installing it. So much for basically just a quick background on like what Arch is or what I'm kind of trying to cover here. So yeah, when you look at packaging, like what is a package anyways, right? I mean, in like the simplest sense, I would say it's just a compressed file that contains a bunch of other files that you dump on your file system of your local installation. These are usually compressed files, of course. We have a bunch of files that describe metadata about the package or about in which context it was built in. And then there are scripts that run actions post-installation or pre-installation. They're kind of special. They're not really of our concern in this kind of talk or this context, but the files describing the metadata are, and this is mainly what this talk is about, actually. So we have at least 4 files describing metadata. So we have the build info file that covers like the build environment information. So with which packages was this package built, yeah, and with which tool also, of course. We have the .m3 package, which file, which is basically just describing the package contents. It's based upon the libarchive m3 file format. We have pkg info, which is the literal package metadata. So what's the name of the package? What are the dependencies, etc., etc. We're going to look a bit further into how they look like further down the road. And then we have the source info, which is basically a package source information. That means it describes the sources of the package, like what do you need to build this package, as in how do you download where do you download your source tarballs from, or what Git repository did you check out to build this package with. And it's a bit of a specific format because, as I noted earlier, we have pkg builds, which are all bash scripts. And if you want to make use of a bash script or the contents or the evaluated tokens in there, you would need to evaluate the bash script, and for that you would need bash. So ideally, if you want to consume the metadata of a package or the sources of a package, you would not necessarily want to execute bash anywhere, but you would rather have something that is a descriptive file format. That's why source info exists. So here's a nice example. I'm just using like the Z standard package. It's actually by Jelle, who sits over there. And yeah, this basically describes like the version, the name, etc., who packaged it, when it was packaged, in which directory it was packaged, what options were used, which packages were installed while this package was being built, etc., etc. So there's a lot of info in here. This is mainly being used to actually be able to reproduce the package. So if you have reproducible builds, you use a file like this to ensure that your environment that you want to reproduce the package in has the same packages installed. And then you can later on say, okay, this is package A, package B, both are bit for bit identical, and means I can reproduce the package. Oh, that's the wrong direction. Yeah, M3 format is a bit more involved, a bit more programmatic actually. So here you see it's a bit based on like actions where you set specific identifiers for files, the UID, GID, and mode, and so on, which you can later on override per file. It's quite specific. There's a man page linked basically in the M3 entry also. So that was conveniently reused basically because it exists already and is quite specific. Then we have the pkg info file. And here you see it's really just metadata. Some of it is a bit duplicate. You might have seen this in the build info file already. It has basically all the stuff that you would see when you would ask pacman like about this package. When you would type in pacman -Q I, you would see this kind of data pop out. The source info is, as I said, derived from the pkg build and basically just encodes the data that you would have in a pkg build. That becomes most apparent, I guess, when you scroll down and then you see all the source links here. This is, where it was downloaded from. These are the valid PGP signing keys and the checksums and everything. And yeah. So going further, you would then wonder like, where do packages actually end up? And that's the package repositories. Once we've built them, you have like a huge directory in which all these packages basically end up. That's architecture specific. So currently we only have one architecture that we support. And yeah, the packages and signatures, they live basically alongside these repository sync databases. And these files, they describe the state of the repository. They explain what is in the repository. This is basically publicly accessible. You can have a look on random mirrors and they will all look the same ideally. And Pacman then downloads files from these directories and synchronizes that against its local state to figure out whether it needs to update anything or not. So yeah, roughly this looks like this. You have the package files. You have they actually live in a pool directory because that way we only need to shift around symlinks. That's a neat kind of little setup. And then you have the database files here, the .db and the .files. A bit more on that now. As mentioned earlier, they live alongside the packages, and they contain all the info about the packages in that repository. So you only need to download that file to know what is in the repository, basically. As you noticed up here, we have like the .db and the .files. So one is only metadata, that's the .db, and we have the metadata and file info, that is a list of files in the package, basically, that's the .files. Yeah, we may have detached signatures for that as well, but currently we don't. And yeah, this is used by Pacman directly to download and figure out what to update. If we zoom in on the fact of these sync databases, then we have like the default sync database, which is only metadata. It has these desk files, and the files sync database, it has desk files and files. Now it gets really confusing. Yeah. So this is literally, yeah, about the specific version of a package in a repository and the files that a package in a specific version in a repository contains. Yeah, to use that standard again as an example, this is roughly how this looks like. We have a bunch of specifiers that are used as headers here that largely contain information from the package directly, with very few exclusions that relate directly to, for instance, .pkg info files. And yeah, the files database entry is really kind of like a bare representation. It doesn't know anything about like file modes, ownership, or anything like that. It's literally just to allow you as the user of Pacman to search for files using this database. So yeah, to get a bit more into like the relationship between all of these gears, basically, we have the package building tools, that is in our case DevTools, which underneath uses make.pkg. And that then hands off to the repository management, which is dbscripts. And then we have the package management on the user side, basically consuming the packages from the repository. Yeah, so we have the package file that contains metadata and, of course, the files that you install. We have repository management that consumes these and needs to figure out certain aspects of these packages. It basically needs to extract PKG information and then use that to create this sync database from. The package manager on the other side then consumes the sync database and translates that into like local comparison states, right? Where it looks up in similar description files locally, like, oh, I have this package installed, I need to update it because it's in a higher version. And in special use cases, we have rebuild tooling that basically consumes package metadata, in this case only build info, probably also other things, but build info is basically the moving part here, where it describes and helps the rebuild tooling to figure out the environment in which to recreate the package. You can check this out on reproducible.archlinux.org. We have a nice website that basically lists like the reproducibility status of all the repositories that we have and the packages that have issues at the moment. So yeah, this is a lot of background. I'm sorry if I'm kind of like text balling you here, but it's kind of necessary because of like further motivation slides, I guess. So why am I even talking about like oxidation of things? Of course, I mean, Arch things are quite old. The distribution is now 21 years old. We have tooling that is as old as that and is legally able to drink in all states of the US, I guess, by now. And yeah, as you can imagine, I mean, you accumulate a lot of stuff over the years, a lot of special use cases, a lot of workarounds, a lot of technical debt, legacy, and it's just a factual remark here, I guess. And there are also closed loops, and this is the main issue, or the I would say like the main topic of this talk actually, that we have the Pacman project, which encompasses Pacman and make.pkg. So it's both the defining factor for how to build a package and how to consume it. But in between, as I showed earlier, we have, for instance, dvscripts, which is the repository management software. And so the changes to internal files, like the metadata files that I showed to you, that is basically only introduced once make.pkg changes. And make.pkg is bash. Pain. That is not so pretty. So this also in turn means that changes to the internal files may break things once Pacman updates. So if you have a project that kind of relies on internal state files, then you might run into issues if you're not aware of that. Yeah, so to get a bit more into the details here is that the specifications that we have, they're not really specifications at all, actually. They're more like a moving target most of the time. And apart from build info, there is actually no versioning of these specification files. So all these metadata files, they don't have a specification, actually. They exist in a specification-less format. And as you can imagine, validating that or even writing a specification that is based on bash, it's pretty hard and not very pretty. To my knowledge, there are no unit or integration tests to actually ensure that the metadata files are correct or that they only contain the data that is supposed to be in them. At least not in the Pacman repository, as far as I know. And as most of this ecosystem is kind of bash-based when it comes to building and consuming these files, the repo management dvscripts is also written in bash and therefore quite limiting and dangerous because we do not have transactions. There's no rollback, so we often run into some weird little issues that are not so pretty to resolve anymore, where you have like inconsistent database states or something like that, and it's just not very pretty, and you need to take care to not break stuff, or you need to at least be aware of there being a lot of issues when you update your packages, on the packager side that is, not on the user side. Hence, I started project that basically sort of emerged from the ArchConf in 2019 in Berlin. We started discussing a bit like how to resolve issues around management of the repositories, because dvscripts is wonky, although it has a huge test coverage, I would say, but it's just not. Bash is not really up for the task for this kind of project, I would say. So I started working a bit on RepoD over the past years, which is meant to be transaction-based, and it's also pretty configurable, I would say, to eventually replace dvscripts. It's fully validating the internal states, which means all these files I showed to you earlier, by the use of pedantic models. But that also means it's Python, and that's not very fast, necessarily. It generates the sync databases, the ones that contain the desk or the files, via some intermediate JSON, and that contains all the metadata. So it basically has a state repository that contains all info of the entire repository to be able to recreate a database from scratch just from that state. That was the idea behind it, to be able to just reconsume everything and be able to tell via state where we are in time at all times, basically, to have an overview and to be able to search that too. It currently features a repod file that's like a small command line tool that allows you to interact a bit with package files, but also with the repositories. The repository use is a bit limited at the moment. It doesn't really do a lot of the actions that it should be doing yet. But it's already very interesting to do some introspection with it too, when you have a package file. But as you can imagine, that thing is huge. So we run into the snake problem eventually, and to untangle that, you basically require a lot of custom parsers because there are no specifications. So everything is basically on a floating spectrum here. That's brutal, I noticed. Due to only having a reference implementation in MakePKG or repo-add, this is all quite, brittle in the way that once anything in MakePKG or Pacman changes, repod is broken. And that's not very, very nice. Looking around before and also after, I noticed that there are a bunch of parsers and attempts at kind of having different parsers for different languages, and there are like a bunch, like Python source info and source info RS, for instance, for just parsers, basically, no specifications, for Python and Rust in this case, just for the source info files. There are a bunch of other ones for the other files in all sorts of varieties and feature completeness, basically. And as you can imagine, that's kind of not so pretty, because as the spec is already really non-existent, you have a bunch of parsers that also do wildly different things, potentially. It's fun. I noticed with the use of repod that all the issues that all these metadata files have, or the packages that we produce, you can only find out after the fact. So you build the package, you push it to a repository, and then repod has some automated pipeline that basically goes through the entire thing and then finds like a gazillion packages that are broken, or broken as in they're not really up to spec, basically. And it would be nicer to prevent that from the get-go, I guess. That's where the crab comes in. Yes, right? As you might have guessed, we are in dire need of specs. And we need to kind of figure out how to have them in a versioned way, to distinguish like the different versions of these files. Sometimes we may add or remove certain specifiers in these files. And for that we need file parsers, writers, and ideally we want to have them be compatible or be integratable across languages and not write them specifically for Python, specifically for Ruby, etc., etc., but have them basically available across languages. And as we want memory safety for that, and we want speed, the crab is the animal of the day, I guess. So some time ago I started writing ALPM types, which is a library that starts to abstract away some of these types that ALPM software needs, which is short for Arch Linux Package Management. There's also the short in libALPM, in case you know that library. That's what Pacman uses or defines. And this is basically low-level types for specifying all of these files and or the fields in those files, and figuring out how to add them on a need-to-have basis is really where this library comes in. Basically, we want to have specs, but we can't necessarily do them all at once. But there's overlap, so we can start with one spec at a time and add to this common library to add more and share them across all these tools. As an extra goodie, we already have a version comparison that is compatible with the libalpm version comparison implemented in there. That's quite nice. It's kind of nice and funny because we first did an implementation in Python and now there's one in Rust. Yeah, it's kind of clunky because the version comparison is really weird. It's an old algorithm taken from RPM actually. Yeah, so who knows? Maybe we change that in the future too. So next up, I started working on ALPM build info, which is, as you might have guessed from the name, for writing a build info specification. This currently lives in a man page per file version. Currently, I've only implemented the first version of the file, and there will be a next one that is based on that, basically. And yeah, it comes with a command line tool to verify and write these build info files, which is kind of neat, and brings me also to the further things that we might do in the future. Yeah, we've only touched ALPM build info so far, but there are more specifications that we should do and should have that are, explaining how these files should look like and what they should contain and what they should not contain. Of course, ideally this would also encompass desk and files because these are exposed to external software, not only to Pacman, but they need to be created and also validated by software that manages the repositories. And need to be understood. So to have a universal spec for these files would be very good, but that's probably after we finish up on the package-specific ones. Eventually I would like to, of course, replace the current implementations that we have that are bash-based with, for instance, ALPM build info, ALPM pkg info, etc. in make.pkg, so that make.pkg calls to these binaries, and we are ensured that we have a validated file basically created in a specific file format that we can, pass on to this binary. Ideally, we also want to have then exports for other languages. For Python, Maturine, for instance, comes to mind there for exporting this and exposing this. And this would cut down a lot of redundant code currently existing in repo.d, which had to implement all of this stuff to be able to validate what it's creating. And ideally we profit, and not only us, but the users too. This brings me to the money thing. As you may have guessed, we are all basically a community-driven distribution. So this is not a distribution that is funded by a company such as Red Hat, etc., or Canonical, which fund efforts like Fedora or Ubuntu, etc. So as such, our developers are not paid. So in case you are able to or want to fund this effort, please reach out. You can do so either via Arch Linux projects on Libera chat or on the mailing lists, or directly to me if you want to. More or less, that's it. Thanks for listening. If you have any questions, I think there's a mic coming up.
Yeah. So if there are questions, feel free. I will come to you, give you a mic. No questions, guys?
Yeah, thank you. Thank you for your talk. Is this on? Yeah? Okay. Yeah. You can't hear it when you speak into it. So, my question is, it sounds like a really big topic with a lot of work. Are you the only person investing time in this at the moment?
At the moment, I am the only person, but Orhun over here is also interested in working on this. To be able to sustain this also like financially, at least I have applied for funding for this, but I'm not entirely sure if this works out or not. So yeah, this is always like an open topic. Like infrastructure work is usually a bit like no one sees it as very important, you know, until it breaks.
Okay, thank you.
So about funding, is it like possible to do some Arch developers offer sponsors to like work on certain feature? Like, oh, I can pay you to work on this, or it doesn't work like this in Arch Linux?
We don't really have it in any setup, I would say, for Arch Linux. We're not really in this position, I guess, because our setup is so loose that it's mainly like singular persons working on their field of interest, basically, and or what they have the time for. As I'm a freelance developer, I have like more time to be able to allocate my time, or I'm more free to allocate my time than someone who has a 9-to-5 job at some company, right? So this also gives me more freedom personally, I guess, to accept donations, accept external funding to work on a topic for a limited amount of time, etc. So yeah.
Okay, thank you.
Thanks for the talk. You mentioned upstreaming the work eventually. Is there an RFC process in Arch Linux, or how does it usually work? Do you switch it over when all the other maintainers are asleep, or how does it?
That's how it usually works. No, we do have an RFC process, but it's not necessarily tied to a specific project only. It's more like an overarching, pun intended, process that is more basically for our distribution as a whole, how to work and how to package and things like that. So this would either go via a merge request towards Pacman or the Pacman repository, or yeah, an RFC would potentially also do. In this case, actually, it would probably make a lot of sense to kind of clarify and kind of set this in stone in an RFC. It could make a lot of sense, actually.
So now that you have some experience with this, having implemented it in like 2 languages, maybe you can also compare it a bit. So I also rewrite a bunch of things in Rust, not just for fun and giggles, but you know, because it actually has some, well, pros to it. Especially because I don't know Python myself very well, but I can read it and then translate. So when I need to fix some software, it's easier for me to port it to Rust. How, from your perspective, did you or like?
I mean, Rust, at least for me, had a bit of a steep learning curve in the beginning, but I like the language quite a lot. And compared to Python, especially when you look at RepoD, it's as soon as you have like really a larger complexity going on, it gets non-trivial to test that eventually, because you need to have test cases for everything, for literally everything, because it's too wonky, too unspecified. Like, what is the input? Even if you specify the input types, etc., it's merely a suggestion to Python, right? So you need to be really kind of aware of like these edge cases, and that makes it brutal to test sometimes. So the test suite is quite long and yeah, just not so nice to work with in comparison to Rust. So you write tests for specific use cases there, and the execution time is much faster, right? So it's a huge difference for sure.
Thank you.
Okay, so do we have some more questions?
A quick follow-up to what you said. You mentioned that you want to expose the types to Python eventually. I wonder if it makes sense to continue using Rust entirely, given the fact that in Python you have a runtime, and I don't know, maybe I wonder what's your take on this?
Yeah, this is was mainly aimed at not the types, but the file specs, so the file parsers and so on, so that you can use them natively in Python, basically. Not so much about the types, because I think the API surface would be too brutal, too large to cover. Doesn't make a lot of sense, probably. And yeah, I've been thinking about this too, to rewrite things further then, but I'm kind of now like at the lowest level I could get to, basically, to change things for the better. And so when I've dug myself out of that hole again, I will probably continue in RepoD, and need to reevaluate how to proceed there. But yeah, I agree. It would probably make a lot of sense because of speed, mainly. Not only speed of execution, but also speed of development, concurrency, etc. And yeah.
Okay. More questions? From my point of view, I think we're at the end of our question queue. So thanks, David.
Thanks a lot.
Thanks for the talk, and for the audience, feel free. Enjoy FrOSCon and have fun.